In this video, we'll have a look at equivalent fractions and what they actually mean and how we can use them. Have you ever been faced with a situation where you may have been offered two different pieces of cake? One of them may be this piece over here, or someone might offer you two of these smaller pieces. Which one would you take up? Are they the same? Are they different? Is one bigger? Is one smaller? Well, let's have a look at them in terms of fractions. So if we were to express this big piece here as a fraction of a whole, we could call that 1/2 of a whole, one part out of the total of two. Now if we're looking at the two smaller pieces, they are 2 out of a total of 4 pieces, or 2/4. Now, is 1/2 the same as 2/4? Well, that's where equivalent fractions comes in. Let's see if we can do something to the 1 here and the 2 to make them the same as the 2 and the 4. Well, we could multiply the 1 by 2, and fractions being the way they are, we must do the same to the top and the bottom to keep it fair. If we multiply both of them by 2, then what we end up with is 1 times 2 will give us 2, and 2 times 2 will give us 4. So in actual fact, they're the same. Those two fractions that we had originally, the 1/2, or 1/2, and 2/4, are equivalent or the same. So in the previous example where we multiplied the top and the bottom of that original fraction by 2, what we're actually doing is multiplying that fraction by another fraction. So we're multiplying it by 2/2, or a whole, because the denominator and the numerator are the same thing. Whenever we multiply a fraction by a whole, it doesn't actually change it. So it still is the same thing, or it's still equivalent, because we could also be multiplying by 1, that's another whole. We could also multiply by 3/3, or 5/5, or even we could multiply by 1,000,000, I'm not even going to fit it in, over 1,000,000. And because we're multiplying by a whole, the fraction doesn't actually change its value. They're still equivalent. Let's try and make a few equivalent fractions of 1/5. Well, we could multiply the top and the bottom by 2. That would give us, well, 1 times 2 is 2. And then on the bottom, 5 times 2 is 10. So we have 2/10. So that's one equivalent fraction. We could also multiply 1/5, same as last time, by 3. Whoops, where's my pen? So that would give us, on the top, 1 times 3 is 3, and on the bottom, 5 times 3 is 15. So 1/5 is equivalent to 2/10, and 1/5 is also equivalent to 3/15. What about these two here? If they're both equivalent to 1/5, are they both equivalent to each other? Well, they are. Let's have a look at another example. So in this case we have 2/6. Now, to make one equivalent fraction, you could multiply the top and the bottom both by 4. So that would give us, on the top, 2 times 4 is 8, and on the bottom, 6 times 4 is 24. So we'd have 8/24. We could also multiply by 5, and I'm just picking random numbers here, by the way. So if we multiply the top and bottom by 5, well, 2 times 5 gives us 10, and 6 times 5 gives us 30. So we have 10/30. And just as we can multiply the top and the bottom by the same number, we can also divide by the same number. So I know that 2 goes into both of these, so maybe I'll try dividing the top and the bottom both by 2. So if I do that, I'll get, well, 2 divided by 2 gives us 1 on the top, and 6 divided by 2, or 6 in half, gives us 3 on the bottom. So we've got 3 equivalent fractions. We have 8 24ths, 10 30ths, and 1/3. So the key thing to remember is if you're multiplying to make another equivalent fraction, you need to multiply by the same number on the top and the bottom. And when you're dividing, you need to divide again by the same number, and it makes it easier if it's a number that goes into those two numbers. So for example, 2 goes into both 2 and 6. In this problem here, we're given 2 equivalent fractions, but they've left out one of the numbers. So we have to try and figure out what fits into that box. Well, let's have a look at the denominators of the 2 numbers, so 10 and 30. Now, thinking back to the other examples, what would you have to do to 10 to turn it into 30? Well, you'd multiply that 10 by 3. That would give us 30. So using the same rules as last time, if you do it to the bottom, you must do it to the top. Keep it fair and keep it balanced. So 7 times 3 will give us 21. So in this case, the equivalent fraction is 21 30ths. We have another similar example, but in this case, the missing number's on the bottom, or it's the denominator. So let's use those same ideas to tackle this problem. So if I had 35, what would I have to do to turn it into 5? Well, if I multiply 35 by something, it's actually going to give me something bigger. So this one must be a divide. So I can divide 35 by 7, because that would give us 5. So if I do that to the top, I need to do the same to the bottom. So 70 divided by 7 gives us 10. So our equivalent fraction is 5/10.